At divergent boundaries, plates move apart, resulting in upwelling of material from the mantle to create new seafloor. These are all the places that you will find divergent boundaries, and you will notice that most of those boundaries exist mainly on the ocean floor. So we're going to zero in on one of these divergent boundaries, and we'll see it says most divergent boundaries, or sometimes called spreading centers, are associated with mountainous areas on the ocean floor called oceanic ridges. So we've been talking about this area, and we've been calling them mid-ocean ridges. You'll see that rift valley that runs through the center of them. As the plates spread apart, the gap is filled with molten material that oozes up from the hot mantle, and the molten rock cools slowly to make new slivers of sea floor. And we can see that happening here. So this is a divergent boundary with sea floor spreading. And as the plates move, new crust is created at an average of about 2 inches a year. And so as this part comes out here, it gets progressively older as you get farther away from the mid-ocean ridge on that side. And it gets progressively older as you go out this way towards farther away from the mid-ocean ridge. So right here's the youngest seafloor. Then it goes older to older. Transform fault boundaries. Another type of plate boundary is called a transform fault. At a transform fault, the plates will slide past each other, and notice nothing is created, nothing is destroyed here. At a divergent boundary, crust is created. At a convergent boundary, which we haven't talked about yet, we'll have crust being so-called destroyed. But here, none of that happens. This got created or destroyed, and here's some places where you have some transform faults. This one right here is a very famous transform fault called the San Andreas Fault. The San Andreas Fault is associated with that. So they choose at first to take us here to show us a transform fault. And at first you might look at this and say, but this looks like seafloor spreading. And it is going to show seafloor spreading, but there's also a transform boundary present. Look right here where these two plates meet. That's a transform boundary. And this plate is sliding this way, and that plate is sliding that way. And so right in this area, we have a transform boundary. Here, some transform boundaries, like we talked about earlier, San Andreas Fault is associated there. Here, out on the west coast, we also have divergent boundaries. So we have transform boundaries here, we have divergent boundaries. And then this is a convergent boundary right here. And so when we think of the western United States and California and Oregon and Washington, we think of earthquakes. And now we know why, because they have all three kinds of plate boundaries out there. So here's the San Andreas Fault. And part of California is on this Pacific plate, and this plate is moving north. And then the other part of California is on the North American plate. So here's the part of California that's on the Pacific plate, and here's the part of California that's on the North American plate. And they're moving in opposite directions. They're slipping past each other. Convergent boundaries. While new crust is being created at divergent boundaries, an older crust is being destroyed where plates collide. These boundaries are also called convergent boundaries. So here are all the places where we have convergent boundaries over the Earth. And here's what might happen when two oceanic plates converge, and we'll look at this again later. You can see that one of them begins to get subducted. It goes underneath. And this oceanic plate descends back into the asthenosphere, that middle part of the mantle. It's called a subduction zone. A trench forms above a subduction zone every time. And then some of that plate that descends, because some water mixes in with that, it makes it so that some of it begins to melt before it all the way gets down into this mantle. And then that melted material begins to rise and create a volcano on the other ocean plate. And we'll look at that in a minute. There's 3 types of collisions. We can have an ocean plate collide with a continental plate. We can have 2 oceanic plates collide at their boundary. Or we can have 2 continental plates collide at the boundary. So we started looking at this one, I believe. It's going to show ocean to ocean. Nope, we're going to look at ocean to continent first. So let's see what happens when ocean to continent collide, and you can probably predict a volcano is going to result. So we're going to go to South America. We have over here, this is the Nazca plate, and over here, this is the South American plate. And the Nazca plate with ocean crust on the edge is beginning to be subducted underneath South America. You can see that some of that oceanic lithospheric plate is beginning to melt. This is also starting to buckle up just because of the collision here, and then also from this material rising up, and we're going to get a chain of volcanoes. It's called a volcanic arc on this continent here. And what we're really looking at is the Andes Mountains in South America. They're a chain of volcanic mountains on South America on the western coastline that are created because of this Nazca plate being subducted, melting, making these volcanoes, and then of course the edge of the continent is getting crunched up too. The Cascade Mountain Range, which includes Mount St. Helens, is created this way. It's another oceanic plate called the Juan de Fuca plate going underneath North America. When 2 oceanic plates collide, this is a picture of a volcano erupting. This is Mount Fuji. We will come over here around Indonesia, and we'll see that 2 oceanic plates are colliding here. The denser one gets subducted. We make a subduction zone. We make a trench right here. This descending plate some of it begins to melt and get loose, and we're going to see volcanoes are going to be formed, except this time the volcanoes are going to happen on this other ocean plate. Eventually, these will pop out of the water, and we begin to form islands. And so here we have a chain of islands created by volcanoes. Those are called island arcs. Here's a satellite picture of a chain of volcanoes that are in the ocean that are just created because of a subduction zone and the subductive plate melting. The volcanoes of Japan and the Philippines are part of an island arc that are formed this way. And the last scenario we have is, what if we have 2 continents converging at a boundary? So we are going to go here to where the Indo-Australian plate is colliding with the Eurasian plate. So at one point there was probably an oceanic plate in between them, and as subduction occurred, eventually it got to where that was gone, and we have continent colliding with continent. Now there will be no more volcanoes at this point because there's going to be no more subduction, and we're going to see what happens when continent collides with continent. No one is subducted anymore, so this is just the edge of that oceanic plate going away. And now we just have continent colliding with continent, and no one will go down, and they'll only go up to make mountain ranges. The Alps in Europe, as well as the Urals and Himalayas in Asia, are a result of a convergent boundary. So they say that the Himalayas probably began when Pangaea started to break up, and you're going to watch India move on a plate north until it crashes into Asia. The oceanic plate between them will be subducted away until we eventually just have continent colliding with continent, and now we're making this enormous mountain range right here.